Welcome to SourceCAD. This video is for civil and structural engineers who want to learn all about designing structural members using a project-based approach and robots structure software. In this video, a simple reinforced concrete structure is used as a project to explain all the details in a step-by-step way. Essentially, if you are new to structural engineering, then this video is for you. The video starts with the basics overview of software and project, and then you'll move to material selection, modeling, applying loads, meshing, boundary conditions, and running analysis. And then we will learn about designing and detailing concrete and structural elements. Finally, we'll wrap up with documentation and data export. You can also get a certificate of completion for finishing this video series all for free. I'll let you know later how you can do that in this video. So with that, let's get started.
I'll start by running my RSA software. So for my case, I have the RSA 2023, the Robot Structural Analysis Professional 2023, and I'll just run it. In the meantime, I can guide you on how you can be able to get this software and the requirements you require for your system. So I'll head to my browser. In this case, I'll be using the Microsoft Edge, and this is a browser that I have here. And then we're going to simply search for Autodesk Robot Structural Analysis. So click on this once. And once you do that, this will be the results that will be brought to your screen. So if I was to click on the first result, let me just click on this one. It will give me a hyperlink to another website. In this case, it is the Autodesk website. And make sure you have this padlock so as to make sure that it's the secured website and it's not a fake website. And under this, we have the robot structural analysis. So you can simply sign in, and just under that, we have the download the free trial, or you can buy in the collection. So there is basically the AEC, the Architectural Engineering and Construction package that usually comes from Autodesk that you can actually download and have different packages such as Autodesk Revit, Autodesk Robot, so on and so forth. So under this, you can have a quick overview. So it simply says that the Robot Structural Analysis Professional is a structural load analysis software that verifies code compliance using the BIM integration workflows to exchange data with Revit. So this, I will go through this so that you can be able to understand how this is usually done, and it helps you to create more resilient and constructible designs that are accurate, coordinated, and connected to BIM. So after going through that, you can click on See System Requirements, and just a new hyperlink will be created, and it will redirect you back to the Autodesk website. So make sure you still have this for security. And down here, you can find your operating system. So for this version, so this is for 2021, which the support was released in 2023. So I believe if you have, let's say, Windows 8 going all the way up to, let's say, Windows 11, for this case in 2024, when we're recording this video, you can be able to run this specific software. So the browser that you need for your case will be the Microsoft Internet Explorer, that is 11 or later. The processor you require, it's not defined, but just the support is an SSE2 or a higher one. And then the memory you require, it's about 8 GB, the display about 1280, and the disk space you require is about 1 GB, and these others, you will look into them depending on if you're using an online software or you're using an offline software. So having gone through all this and you're satisfied and you have already downloaded your software, we can now look into how to use this specific software. So for my case, I've already launched it, and this is the basic interface on how it looks like. So once you start your software, this is how it usually looks like, where you'll have your logo here for the RSA, then you'll have file. So from file, you can be able to create a new project, open an existing one, or you can have the recent documents that you are running over here, or you can exit from here as well. Not only that, you still have more or less the same commands here. So you have the new project, so you can select from the existing templates that you have here. Then you have the recent projects, which you can go through. Depending on how many projects you have, you can just scroll like that. Then you have notification in the event that you have any notifications from the projects that you're working on. Then under this, you still have new, where you can create a new project using these templates and even more templates under this. So if I was just to click on this once, this pop-up window will be shown. So under this, we have different types of templates, but in this case, we'll be focusing on the building design template. I've already gone through all these other templates in our comprehensive course in this website, so kindly make sure you go check it out. Under that, you still have open projects, and if you want to get started, you can have a quick start guide from the website, and you can also open sample models from here. So in this case, let me just open a sample model so that you can see how you can be able to use it. So let's say if you're gonna use the US, let's say 2D frame or something of the sort, like a 3D frame structure, you can just select from here. You can opt to see the preview or not to see it, and then you can also opt to open in repair mode. So I've already gone through why repair mode is important in the comprehensive course that we have, so I won't touch on that one in this video. So once you have selected what you want and the file type is precisely as per the robot specific file type, you can just click on open, and the robot structural analysis will start opening the project. So you have to give it just a few seconds or a few minutes, depending on the size of the project and the capacity of your machine. All right, so our project has now opened, and this is basically how our user interface looks like. So over here, we have our workspace, or where we do our drawing and our design, and we can be able to visualize. And on this left-hand side, we have our object inspector, where you can visualize and see the objects that we have within our project. So these are the members. If I was to select on either of them, it will be highlighted in the project, and also we'll be given these properties down here about the geometry of this specific item. Not only just selecting from here, but I can also select within this specific model, and it will update in real time here. And if I was to right click within this workspace, I'll be given this other set of commands that I can use either to pan, to rotate, and also to get some settings either for snapping or even check on the display properties. So these ones, I will go through them as we continue with the specific video. So not only members, but you can also visualize the nodes if you wanted to select any of the nodes. So if I was to click on this, a specific node has been selected, but if you cannot see them, you can actually use this view tab down here to uncheck some items. Let's say we want to uncheck the section shapes. So just uncheck, and just like that, they will be unchecked. You cannot see the section shapes anymore. And if I wanted to see them, I'll just click on it and it will be shown again. So the node is a very small point. This is just basically a point of connection between this specific member and the other member. So if I was to zoom in, you can clearly see this number 4 here. This is a node. If I was to select on it, you can see it's somewhat colored yellow, highlighted yellow, just specifying that it has been selected. So after doing that, you can zoom out, and you can also find more options up here. So at the very top, we still have our logo. So this is the Autodesk Robot Structural Analysis logo, which is an R, and it's Pro for professional, and you can still find the same name here. So this is where we find the title of the project that you're working with. It's just basically called the title bar. So it displays the project name. So this is Project Get Started 3D Frame Structure, where we have the results available. So this is just after running the analysis. Right here, you can see it's green. It means that the results are available. Down under it, we have our menu. So if I was to click on this, we have a set of other options that you can be able to find. And if you click on either of them, there's usually a window, this pop-up window that shows other settings underneath. Let's say, for example, we go to nodes and we want to hide the nodes. I can just select that and apply, just like that. Now they are hidden. So these are other settings that are found within this menu bars here. So I'll show you all these settings as we continue with this specific course. Under this menu bar, we have our quick tools. So these are basically tools that you can use. Instead of going File, Save, you can just click on Save. Or instead of going File, Open, you can just click on Open. And so many others are found over here. So this is actually a quick summary or a mini toolbar that are of the most important tools that are used within the RSA software. And under it, we have our selectors. So let's say, for example, right here, we have selected only one specific node. If we want to select all of them, I can just select all, and you can clearly see that all of them have been selected. Not only that, this applies also to members. If I want to select all members, I can select all, and just like that, all of them will be selected. And if I do not want to select anything, I can just click here and just simply go to none. And just like that, they will be deselected. And not only that, we can also select the type of load. So this I will show you later on in the video how we come up with these loads. So basically we have the dead load, which is DL, or in other codes, we refer them as permanent actions. So this is like Euro code. And then we have the live load where we refer them as variable actions in other codes. And you can select various types of loads over here. So currently we have dead load 1, case 1 selected. If I also select on the ultimate limit state, let's say I click on this one, it will be changed and updated down here, and we'll have a figurine here representing on how the ULS is acting. But if I do not want to see these symbols, it's quite easy. Down here under the view tab, we have other types of options. So if I was to navigate to this specific load symbol, if I uncheck on it, it will be hidden. If I check on it, it will be shown. So that's the way we actually work around our workspace here. And these boxes here are just basically our supports. If you don't want to see your supports, you can just simply uncheck them by clicking on this, toggle off, toggle on. It's very simple. And under this, we have other commands, which I will be showing you as we advance with the course. And on this right-hand side, we still have a basic layout of the tools that we still have within our menu bar. So let's say, for example, this is our axis definition. If I was to click on it, this pop-up window will be shown. So from here, we can be able to create our axis for this specific building. So what do I mean? If I was to close on this first, remember we activated it by pressing here. If I navigated to geometry, I can still find the same command here. So this simply means this is a quick summary of the most important tools that are used within the RSA software that you can access by just clicking here rather than going all the way to load, then going to load types. So instead of going to load types, you can clearly see this symbol or this logo here is the one that is actually found here. So that's the way you tend to understand which specific items are found from this side and this other side as well. If I was to go to design, I can clearly see timber here, and I can also see the timber here. So that's the way we check on these items. Just down here, we have where we can select our different levels. But for this specific sample case, we have only one level. But in our video, I'll be showing you how to select various levels from here. You can also change your view from 3D to specifically 2D. Let's say this, and I can view it from the very top. And you can visualize it from this section here, which can actually use also these arrow keys to move up and down the different levels. So let's go back to 3D like so. And this is the way it looks like in 3D. You can also use this specific view box or the view command to change your views either to 2D, something of the sort, or you change it to 3D. If you want to have a realistic presentation, you can click on this and it will give a background, something of the sort, where you can change different items from here. So let's say we close this and we close here. You can also access the same command from here. If you click on this, you can still find the same command which you actually found down here. So this is the way these settings are integrated and they are seamless to navigate within your software. And the most important two items that you need to understand is about the layout. So these are the layouts that we have within our RSA. These are important when you're navigating through different commands. Let's say, for example, you're focusing on members, you can go to members, and this specific layout, let's say a specific template which has been pre-designed by Autodesk, you can use this one to focus on placing your different types of members. So you can clearly see we have this tab of members, we have a member tab here, and we have the model being shown here. You can also find the same tab being shown here. So we have the view, this one here, and you have the member, this one over here. So we can specify different layouts depending on what we want to focus on. Let's say we want to focus on results. If you go to results, you click on stress analysis, it will be focused mainly on the results of these specific members. So you can clearly see now we are focusing on the stress analysis, and if I was to click on apply, it will show the analysis on this side over here. Not only that, let's go back to our default view where we have model and click on start. Under this area, we have our quick launch buttons, which are actually found down here. So these are very quick launch buttons. If I was to click on this, I'll simply go to the display window and it's very quick to launch. If I was to click on this, I can simply jump to any other command that I wanted and it will be brought over here. Not only that, if I wanted to change also my units, I can just simply click on this, and just like that, I can change my units from here. And if I wanted to measure a distance, I can simply click on this, then maybe measure from here to here, and you can clearly see down here, it's been updated in real time. So from that point up to that point, it's 8 meters. And that's the way we use our RSA software within our user interface. So having said that, I'm going to simply close out of this and we are going to start a new project. I'm not going to save anything, so click on no.
Now, before we go further into the video, I'd like to share with you completely free Robots Structure Essentials course from SourceCAD. All the lesson files of this particular video series are available for download from this Essentials course. And basically, this Essential course is the same video that you're watching right now, but in a proper packaged way with downloadables and also a certificate of completion. You can sign up for this course using link in the description of this video and also in the pinned comment. Now, back to the video.
Alright, so now we are back to our home tab or our home area where we can be able to start our project. But before even starting our project, we need to understand what type of design that we want to work on. So to do that, I have shared this folder with you where we have our DWG file. So they are under AutoCAD files. So we have our DWG files. So this one or our DXF files that you can actually import to our RSA software. So having run our AutoCAD, in this case we're running with AutoCAD 2024, we can be able to open it and we can visualize how the architect had placed the grid lines. So this is the axis system where we have the alphabetical order from A to E. So this is alphabetical in the X direction, which you can clearly see here. So X is moving from left to right. And then we have the numerical system, which is moving from top to bottom, and it's the Y section. So we have the distance in between being 3400 millimeters or 3.4 meters for metric system, which we'll be using in this course. And we have from left to right being 4025 or 4.03 meters between each specific grid spacing. So having checked all this, now we can be able to close it from our AutoCAD software and we can launch our Robot Structural Analysis Professional and we can start our design. So first go to New, and under New, select our template, which is a building design template. So once you click on it, it's going to create this specific work space. So where we have our layouts. So you can clearly see that our layouts are slightly different because now we're using a different type of template that has been created by Autodesk, but it's still more or less the same thing. So under this, even if you wanted to change the color of your user interface, you can easily change it from Tools, navigate to Preferences, and under Preferences, you can change the color that you prefer. So we have different presets already given from Autodesk, so you can check the one that you prefer, but I just run using the default one. And if you have a different language that you prefer, you can change it from here. If it's Spain, you can use this and it's going to update accordingly. If it's Euro, it's going to update. Maybe if it's Indian, you're going to update it here and it's going to update accordingly. If it's Chinese, you can update it here as well. So let's go back to, let's say, Great Britain, and you can change the printout language as well. Under general parameters, you can go through all this. These ones we already checked in detail within our comprehensive course that we have within the website. So you can even change how the symbols will look like, so on and so forth, and even change or save it to a certain standard that you prefer. So for our case, we're not going to change anything. Click on cancel, but we can clearly see that the units that we're running with are meters, and you can find the same down here. So meters, kilonewtons, degrees, and so on and so forth. So you can change the units by pressing here, and this job preference will pop up. Or alternatively, go to Tools, then navigate to Job Preferences, and you can change them from here. So you can create a new specific default template that you prefer, so as the one that we created within our entire comprehensive course. So you can see how it's created, or you can select the one that you already have. So it's very simple. You change the units that you want. Let's say for this case, I want to use millimeters for the structure dimensions, everything as millimeters. I can change my decimal places. So this is 1 decimal place, 2 decimal place, 3 decimal place, And if I increase 4 decimal place like that, it will increase. If I click on this, it will reduce. So I want them to be at 0 decimal places. You can change for dimensions, for forces, other items. You can even change the databases from here. Let's say in this course, we'll be focusing on reinforcing bars. So click on reinforcing bars. You can load from the database that we have very simply by clicking on this plus, navigate to the one that you want. In this case, we'll be using Eurocode, so EN, and you can find them here. So let's say Eurocode 2 part 1. So you can click on add, and just like that, it has been added. Just to make it default, you can check on this and it will be made to be the default one. So these other items, you do not need to focus on them right now, like steel design, vehicles, so on and so forth, because you're just designing a simple reinforced concrete building. So wire fabric, will not be using wire fabric in our design. We'll be using the reinforcement bars, but the same principle applies. Navigate to EN. You can specify the one that you want. Let's say this one. Then click on it, then set it as default and change the design code. Let's say the loads, how you want them to be done or to be checked. You can specify Eurocode from here or British Standard or any other standard that you want, or you can load by pressing on this ellipse and you can change how it's been calculated from here, and the formula has been considered for the service limit state, for the ultimate limit states, so on and so forth. So you can click on close. You can specify it for the wind loads as well. You can go to more and you can specify in accordance to the country that you're designing for. Let's say France, Morocco, Norway, Romania, so on and so forth. Italy, you can change from here, and then you can set it as default from here. Let's say I want to set this one. I can set like that and it will be bold, but I want to use Eurocode. You can click on OK. The same with this, more, and the same philosophy applies. And if you want any help, you can just click on help and the pop-up help window will be shown to you. So these are other items for structural analysis that you can go through, but I've already gone through our entire video that we have, an entire course that we have. And after that, you can save it as the way you prefer. Let's say EN Eurocode design, something of the sort, as a job preference, then click on save. And just like that, if you want to access it in future, you'll just find it here and it's very easy to locate. So for our case, click on OK. And just like that, you can clearly see that our units have been updated. If I was to zoom in, our increment will be smaller. If I was to zoom out, our increment is bigger. So that's the way our increment changes from here. Not only that, we can now focus on importing our drawing. So navigate to File, Import, navigate to DXF and DWG. So I've already shared this specific document with you. So you can go to AutoCAD files, DWG, you can specify DWG or DXF. You can select it from here. Make sure you use link, then click on open. So once you do that, this pop-up window will be shown where you can specify the reference point, the insertion point, but I'll advise you do not change these items here. Just leave it as is, but you can change the units to millimeters. So once in millimeters, under layers, you can specify the layers that you want. Let's say we uncheck on all. We want to focus mainly on the grids. So click on grids, click on apply. And just like that, that's the way they're going to look like. So click on OK. And let's say in the event that in our AutoCAD, we want to do some changes. So this is a specific drawing that we have. So I can open it like so. And I can, let's say move origin. So I want to move origin only. Then I can move it, let's say, to this specific point. And this is the way actually you specify your point. So I have specified my origin point. Then I'll simply click on save. So click on save and it has been saved. I'll close out of that. Then I'll drop down. So back in our RSA, you can clearly see that it's saying that it has been changed. Do you want to update the background? So click on yes. And just like that, it will be updated in real time. So that's the power of linking our drawings. So in this part 2, we'll be focusing on specifically setting our structure, creating our supports, applying our loads, creating our members. Then we're going to do our analysis, parameters, check, and then we're going to visualize the results as well as creating reports. So having said that, we have our grid. Now let's create our axis. So to create our axis, you can create either from here, or you can simply go to geometry, axis definition from here, or use a keyboard shortcut of GR to pop up this window, and under this you can specify the axis that you want. So in this case, we'll be using the axis name being RC structure axis, and the type is Cartesian. If you want to learn about these ones, we have gone through them in our advanced course. And under the X, Y, Z, let's start with X. We want to create from the X direction, so from left to right, and the position will be from this point here. So you can click on it just to specify the first point, and the number of repeats from that will be 3, because now, actually 4, because now we're remaining with 4, 1, 2, 3, 4. So I'm not clicking anything here, and the distance in between will be 40, 25. Remember from AutoCAD, but if you don't remember, you can simply click on this measuring tool, and then you can be able to measure within your drawing. So click on measure. So measure from this point up to this point here, and you can clearly see it's 40, 25. So this is correct. Then you're gonna click on add. So after you've added your areas or your different axes, you can see that our numbers are 1 to 6. But in our AutoCAD, it's alphabetical, so A, B, C, D. And you can clearly see that we have repetition of A, B. So we can do away with 1, just like that. Then click on apply. And just like that, it has been applied. But because we don't have the Y direction, it has not been fixed yet here. So let's now apply our Y axis as well. So the position, specify the first point. So I'm just panning by holding down my center wheel mouse button to pan within the drawing. Our first point starts from near 0, so from this point here. So click on this to create our first label, and the number of repeats will be 3. So 3, and the distance in between is that 3,400. If you don't know, just click on that and measure up to around this point here. So you can clearly see it's 3,400. Then click on add. So we have another repeat here, delete that one, then click on apply. And just like that, we can clearly see that they're fitting perfectly with what our architect had. So 1, 2, 3, 4, all right, A, B, C, D, all right. And the way to read it, it's A1. So this is A1 grid. And if you zoom in, our axis tends to come closer. So A1, B1, like so. So having done that, now let's specify for our Z direction where we have our story height. So under this, we have our stories, but we do not have our levels. So let's first specify our levels. So the first level that we want will be at level 0, that's okay. And you want 6 stories all alone. And the distance in between will be that 150. Then click on add. So they have been added, but they do not have the story number. So if I was to click on apply, click on close. If I was to navigate here, we'll see only base, then story 1, then all these others are just RC structure axis. So to modify this to the correct system of labeling in RSA, it's quite easy. Simply navigate to our stories, structure stories here, click on this once, and this one will be shown. And then we're gonna define manually. The number of repetition is 6, and the height is this. Click on add, and just like that, all of them have been added, like so. Then click on apply. So for this one, we do not need this level. Click on apply again. And we can clearly see that now we have from story 1 all the way to story 6. And our base being here. So you can set the base and it will be added to the system accordingly. So click on close and you can see base all the way to story 6. To view this in 3D, click on view. And just like that, it's very beautiful from base all the way to story 6. So having done that, now let's start creating our members. So you'll find out that RSA software is organized in a very good way. So it's just sequential from access to members, then from members, we go to loads, then from loads, we can now go to either providing reinforcement, so on and so forth. So to create our members, you can either create from here. So these are our beams, our columns, or you can simply go to our geometry here, navigate to members, and we have our different members here as well. So from here, we can specify the member type, and you can actually create a new member type by pressing on this ellipse and specify the type of member that you want to create. Is it a column? Is it a beam? So on and so forth. You can change the name. So for our case, we want to focus on RC column. So click on RC column. The section type we can change from here. So click on this ellipse to create your specific new section type. So for our case, the Size of this one will be 400 by 400. It will be a square. And you can change the color if you wanted, let's say to something like green, something of the sort. You can reduce the moments of inertia by checking on this, and also change the material type from here, as well as the gamma rotation angle from here. But for case we're not going to change anything else, just click on add and it will be added here accordingly. So if you already had an existing one, it will be added with a bracket 1 to add it into the system. If I click again, it will be added with 2, or it will ask to modify. So click on close, navigate to this section, and you can do away with a member that you do not want from this section just by pressing on this ellipse. So under this section, you can just leave it as is, but I can show you how to do away with them later on in the video. So now we have our member for the RC column. We can create for RC beam. So click on RC beam. You can specify from the ones that you already have here, or you can create a new one. So let's click on this ellipse and this window will be shown. And under this, you can even change the name to what you want. So maybe I prefer M. So I can change this to 300, the highest to 600, then click on add and it has been added. And I can change this also, let's say to S, to small, and then 300, then add. And just like that, it has been added. So that's the way we specify our section types over here. So the next item will be to place as we create new section types accordingly. So I'll simply go to view, and under view, we'll start to create our columns. To do that is quite easy. Just click on this column option that we have here, specify the type that you want. We want an RC and we want this specific size, so we can use this. Or remember, if you want to create a new one, you can just click on this ellipse and you can still create your new members from here as well. So for now, we already have, navigate, select on this one, and then you can start by clicking the beginning point, and you're creating going downwards. So it means from top to down. So let's create from this side. So from top, so A1 to down. From top, just click once, it's been added automatically, top, then going down, then top, going down, and that's it. So we can visualize it in the plan view. So over here, if you navigate here, click on close, then right click, click on cancel, we can clearly see that we have our columns added, and we can easily copy and paste them to other areas. So select on one of them, right click, navigate to select similar, then select member type, and all of them will be selected. And you can clearly see that there are 4 and the nodes are 8. So the quick and best check to see the number of nodes, if they're okay, they're usually the member of the column by 2, you get the total nodes. So 4 by 2, it's 8, and it's all right. So now let's copy this other direction. So navigate to edit, click on this edit, this window will be shown. I can pin it here just by dragging and dropping. Then we're going to use the move or copy. So click on this and you want to translate it. I'll show you how to do that, but you want to copy it 4 times. So update this to 4, the distance being from this point up to this point, and just like that, all of them will be populated. Then click on close, go back to view, and you can visualize your columns. If you want to see the section shapes, click on this, and just like that, you can see how beautiful it looks like. Let's go back to plan and place our beams. So for our beams, let's start at story 1. And at story 1, click on beams, option 1, specify RC, specify the size. So I know we have created these 2, but they are basically the same member with this one. So click on this main beam first, click on this one to add, and we want to create horizontal beams, not aligned or inclined beams. So the first beam from that point continuously, I'm not pressing any other point up to that point, and then that beam has been added. Then let's change the type of beam here to 300 and 300. Click on this one, the beginning point at A4 up to A1, like so, continuously. So I'm not clicking point, I'm just doing the first and the last, the first and the last. Then close, then right click, click on cancel, then select this specific beam, use the same translation option. We're gonna copy it 3 times. So 1, 2, 3, and we're going to specify the distance from this node here up to that node, just like that. They're done. Then right click, click on cancel, right click again, click on select. So I want to select this beam here. So the distance we can specify, but the distance of copy or the number of copy it's 4 from this node to this node. And just like that, all of them have been populated. So go back to view, and just like that, you can see our columns and our beams have been created. We have deep beams here and we have smaller beams here. So having done that, let's go back to plan, and you want to place our floor. To do that, it's quite easy. So click on floor here, and under floor, there are different types of floors that you can create. Let's start with the thickness. So click on this ellipse, and this option will be shown. So you have homogeneous floors, orthotropic floors, where you can specify, let's say, hollow pot slabs from here, and you can be able to enter the data given from your manufacturer. But for our case, we're not going to use that one. We're going to use homogeneous. And under this, you can specify your new type of floor that you want. Let's say we want to use RC 150, the thickness being 150. You can leave it like so. You can change the color, remember, to what you want. Let's say something of the sort. The material is class 25/30. You can specify from here. And if you want it to be variable along the line like so, or along the plane like so, you can change it from here. But for our case, we want it to be constant, and you can reduce the amount of moments of inertia, as well as apply the default parameters of foundation when you're designing matte or rough foundations. So this one we've been able to go through in our course in depth. So after that, click on add, and it will be added here. Then click on close, and then you can simply select it from the list that we have. Then the model of panel calculation, you can select from here. So let's say we want to work with shell. You can click on shell, but you can click on this ellipse to change the settings that have been considered within the shell calculation option. So we want it to be a finite element method, and these are the items without stiffening of the diaphragm. So you can click on close. The next item is about the definition. So you can define it using contours, different points if they're not regular shape, or you can use a rectangle if it's a regular shape. And under this, you can see the different points, but you cannot just hide it. You do not need to see it. And if you're using inclined slabs, you can uncheck on this, so as to add the inclined slabs such as staircases. So this one we have already gone through in our in-depth course. So for our case, we're just going to do a very simple analysis using a rectangle, and we're going to just be placing it. So our first point here, our next point here, and our end point there. So that's the way we create our slab. After that, we're going to click on close. Then navigate to view, and that's the way our structure looks very beautifully within our design area. So after advancing at this stage, it's always important to save. So simply go to file, go to save, and you're going to save it to this specific area. So I'll save it as RSA under the RSA folder, and under this, I want to call it as RC structure. So it's always important to give it the project name. So for this, I can call it source CAD, and then you can specify the file type. So for my case, I'll leave it as robot, then click on save. And once I save, it will be updated up here with the project file name, like so. And if I go to file, I can also give more information about the project parameters from here. Let's say revision number A, and the face that you're working with, maybe this face, the address that this place is located. Maybe I can specify the area, the city, maybe something like so. I can give some comments, maybe something of the sort. I can give the architect information, maybe something of the sort. I'm just populating all this. You can give even the email, the investor, the contractor, design office, the statistics, where we have saved when it was started, what are the number of panels, and what are the number of nodes that we have, so on and so forth. Then click on OK. So that's the way we save drawings and designs within our RSA software. We can also put a password, so on and so forth, but that one already discussed in our advanced course. So having done that, the next thing that we need to think about is about the loads that are acting on our structure. To do that, it's quite simple. What we usually do, we go to our load, cases. So first we need to define our load type, so that we go to our load cases. So click on load type, and you'll find that we have only one type of load, and this is the dead load. As you understand, this is a self weight of the structure, or the weight that cannot be moved away from the structure. So we can add it. It can be structural or non-structural, and you can change the type of load from here, as well as the label type and the number. So we want to work with dead load. So DL for dead load 1, click on add, and it will be added to the list. The next load is live load. So defined in with the type of category. This one I've already taught in advance in our course. Kindly look at it. So this is live load 1 or variable action 1. So click on add. It will be added here as well as the category. All these others we can be able to create later on in the video, and I'll show you how. So let's first start with these two, then click on close. So having done that, if you were to navigate to this area, we can clearly see that now we have two types of cases. If I click on dead load 1, we can now specify how this load is acting on our structure by going to our load definition. So click on this option once, or even better, if you wanted, you can navigate to load and you can go to load definition. And if you want to have more information about loads, you can click on the load option, and our layout will be updated to loads. So under this, we can clearly see that we have loads being focused on, where you can just select the load that you want. You can go to your load definition just by pressing this, and it will pop up, and you can specify from all these options that we have. So for our case, we'll just focus on the self weight, or most important is the surface load. So let's start with the uniform planar load. So click on this once, and you can specify the weight acting down on this specific panel. So for the Z is the most important, and it's acting down. So let's say around 200 kilonewtons per square millimeter. Remember, this is the density of the concrete that you're using, and the size of the area that you have, as well as the thickness of this area that you have. So within the square millimeters, it can be around 20, and then I'll specify the edge. So first I'll click on add. So I've added it to the system, and then I'll specify the edge that it's acting on. So this edge 32, it has been selected, then apply, and you can clearly see that it has been added to this specific panel. Then after that, I can click on close. Then I'll select the second live load. So this one over here, and it has been updated accordingly. So you also want it to be a surface load. So click on this. We can specify, maybe this is a classroom area or just a office area. We can use -2.5 that is acting along this area. So you can click on add, then specify to this specific slab, then click on apply. And just like that, you can clearly see that they're being added over here. And if you wanted to edit anything, you can just double click over here and you can edit accordingly. So for that, that is satisfactory. For these other types of loads, we have already gone through them in our entire course. So like the hydrostatic, the one is mainly used for water. You can find more information about this in our comprehensive course. So after doing all that, the next thing will be our load combinations. So I can go back to geometry, and under geometry, if you wanted to see the load shapes here, so this is basically how the loads are acting. You can press on this and you can clearly see how the loads are behaving within this specific structure. So now let's apply our load combinations. So you can change the groups that have been included in this case, as well as the cases that have been included, as well as the coefficient that have been used to generate your different loads combinations. So under loads, we can first start with our manual combinations. So under manual combinations, you can specify the combination number, as well as the type of state it's been considered as a ultimate, service limit states, so on and so forth. So let's say we are using the ultimate limit states. We can check on the parameters on the items that are being used, as well as the nature that is being used over here. But for our case, you can click on OK, then click on OK. And once you do that, this pop-up window will be shown, and you can add what you want to be included. So we already know that the dead loads are usually multiplied by a factor of 1.35 for the factor of safety, while 1.5 for the factor of safety of the live loads. Then you can click on apply. And if I was to click on this, you'll find that we now have our combination added here. If I was to click on close, just to close away from this specific combination, we can also find other options such as automatic combinations from here. So from automatic, you can specify the one that you want, either the fully automatic or the simplified automatic or the manual generated automatic. So depending with what you want, you can go also to more, and you can check and uncheck what you don't want. If it's accidental or fire, you can uncheck them, and then you can just simply add them to the group. Depending with the active cases that we have, for our case, we have two types, the dead load and the live load, and the groups that can be considered, as well as the relations between them. So once you're satisfied with that, you can just simply go to next. Then you can check the ones that you want. So let's say we want all of this. Then you can click on generate. And if you're to go to this drop down list, you'll find that all these loads combinations have been considered. So after going through our load combinations, which will actually also just find them here, the next item that we can do is to propagate or to copy and paste the information that we have about our structure from this level all the way up. So even before doing that, let's simply just create a very simple staircase on this side that we can be able to use to navigate going up our structure. So to do that is quite easy. I want to add one simple access here, which I'll go to my access manager. So I'll just simply go here, and from here I can add my new access. So I want to create a new one, and I can call it stair, and my direction in the X, it will start here, that's the position, and then I can have only 2 repeats, and the distance in between can be around 1.5. Then I can click on add. So this is a repetition, do away with 1. So this is the edge, the center, and the edge. And then for the Y, so this is basically this other side, we can have it start here where we want it to be also at the center. So let's say position start here, the repeats will be only 2, and the distance in between will be a distance of, actually just need 1 more, so only this, and the distance will be 3400. I'll add that, and that's what we have. For the Z, we do not, I can actually add 1 for the Z because we want it to go up 1 flight, and then we can be able to copy and paste it. So I can do that, and then I can just simply click on add like that, and then click on apply. So if I was to zoom in slightly, I'll clearly see that for X axis, we have an axis here, which I can actually use vice versa. So apply like this so that they do not clash with one another. So we have A, B within this area, and this other side is vice versa. But you can change the specific naming if you wanted to do so. So for now, first leave it as is, but this is quite small, 4 millimeters. This distance here is quite very small. So what we're going to do, we're going to delete all of them. And the position for this was here, the first one. So let's delete all. Let's first remove everything. The position of this one is this one. Then the number of repeat is only 2. And the distance in between is 1500. Then click on add. Then right now is right. Then click on apply. Okay, now it's making a lot of sense. So our first rise will be around here, then turn over here. So for this case, we need to add 1 landing area. So under this, we can add 1 area from this point, 0 repeats, and the distance will be, let's say 1500, then add a 1, then add, then apply. So if we were to zoom in here, 1500 is quite big. We can just reduce this to, let's say, like that. So I can do away with 1, then apply. Yes, so right now it's making a lot of sense. So one side will be the riser, landing, then like that. And this will be somewhat of the entrance. So that's how our staircase will be. So I can close from that, and we can start to create our specific staircase riser on this side. So let's go to view, and the viewer can pan a bit and orbit a bit so as to create our first riser. So our first riser will be here. It will go up here, and then it will turn. But for now, I do not need to see all this background. So for me to deselect the background is quite easy. I can just click on it, and it will be highlighted here. Remember, you can also change the color. Let's say if you want to change the color to something visible like this one, we can change it to from here. So first select it, And then if I don't want it on, I can just click on no. Now it has been hidden away. So now let's create our first area here. Quite easy. Our first step, our first rise, go back to this. We're going to select our rectangle because it's actually a regular shape, but we do not want it to be a horizontal slab. So go to that, go to geometry, or let's use rectangle, sorry. Our first point, our second point, and our third point, move very fast inside here and update it to, so if you move away, it's going to change, and update it to 1500 and click on apply. And just like that, we have our first rise. So let's create our second one. So our first point will be this point here, our second point being here, and our third one being here. Move very fast. So from here, move very fast inside, update all of this one to 1500. So the good thing about RSA, you can just Control C, Control V, then click on apply. And just like that, it has been added. So now let's add the next one. So make sure you click on point 1. So we want point 1 being around, I believe it's around here, or I can just hide my section shapes. So from here, point 2 being here, point 3 being, yes, here. So I'll move very fast inside, and you can clearly see that it has picked up the point, and I'll just simply click on apply. Just like that, if I was to orbit around here, you can clearly see that our risers have been added appropriately. So I can click on cancel, and we can see how our staircase looks like. So we can now add our columns over here very fast, and it's quite easy. Go back to column. We're going to change the type of column size that we have here. 400 is quite big. So click on that to create a new one. And the size of this one will be 250 by 250. Click on add, click on close. So we want it to go over here. You can change it to go down. So we can specify where we have story 1. You can clearly see that we have a connection from that point. So over here, down, done. Over here, down, done. At this section, or at this section, we can add it here so that we add a beam on this other section. So if I was to turn on my section shapes, you can clearly see how it looks like, something of the sort. So we can add a landing beam on this other side instead of having a column in between here. But where we might need a column is actually here, but as long as we have a strong beam. So let's go back to beam. So for the beam, we're going to just be using 300 by 300. Not an issue. Just pan a bit, zoom in. So I want to start my beam from this point, connect it to this main beam here. From this point here, connect it to the main beam there. So for this others, we want to add a beam at this level here. So we can clearly see if we orbit our node, our cursor to this node, it's actually picking it up and it's updating it accordingly. So we can turn off our object shapes, our section shapes, so that we can be able to add our pins from that point to that point. And that's the way it's actually done. So if I was to turn on my section shape, just to confirm that everything is alright, everything looks good, just that one column is missing here, so as to carry the weight of this specific beam. So take your column, we want it to be down. So from this point, just like that, we now have our column and place our last beam from this point to that point, just like that. So here we have our rise, our landing. So we need just to create a very simple landing here so that we can be able to connect now from this point going to the other side. So we can click on close, go back to our axis. We can go to our plan. So we want to add on this side, which is the Z area. So from this point, we want to add only one repetition, distance of 1 meter. Click on add, click on apply. So if we were to zoom in, this is actually negative. Then we can click on apply. We need to be careful because I'm actually changing the other one. Let's try to undo. So I've been able to undo the change that we had done initially. So I'll click on apply for this one. No, I will undo, then click on close for that one because we were changing the main axis. So go back to this axis and make sure you select the right axis here, then change it here. So I want only one repetition, negative the direction, click on add, then click on apply so that we add one landing here to carry the weight to this other side. So once that's done, click on close, go back to view, and we're going to just simply select these members that we have here. So this one, control to select multiple like so, then simply click on our copy. So you want to copy and only one repetition. So from this point here, or you can turn off the section shapes to be sure, from this point to this point, so that we have this specific area, and then we can add one beam from that point, then close, then create a floor within this area. You can use a rectangle from this point to that point to that point, just like that. So that's the way it's done. So for this specific member, we do not need it for now. So this one and this one, you can just simply select them, control select like so, because if we copy and paste these members, will be okay. So everything is okay like that. Everything is all right like so. So if we copy and paste to the next levels, everything will be okay. But remember, these new members do not have any specific loads added to them. So what's pending is just to add our live loads to these specific new members. So if I was to click on this, you can clearly see that no live load has been applied to them. It's not an issue. It's quite easy. You just simply go to load definition. So for here, we need to make sure that we are working with live load. So for us to apply our loads to this newly added panel, it's quite easy. So what we need to do is just first, let's hide our section shape so that we can see our panels clearly. So this is our first panel. Hold down your control so that you can select multiple like so. So once you have them selected, we're going to simply just go to our load types so that you can select the load type that you want. So this is load 2, our load definition, and then we can specify surface. So this is a surface that you want to apply, and this is live load. Make sure it's live, then click on add, because you want to add these specific panels to that specific load, then click on apply. So once that's done, you can clearly see that the live loads have been applied. And if you want to apply the dead load, so simply click on the dead load over here, and it will be updated accordingly over here. Then go here. So over here, we need to make sure that it is updated as well. So currently it has not, but that's not an issue. You can just select from here as well, and it will be updated. Go back here, make sure that you give it the correct information because the thickness is still the same. So click on add, still dead load, click on apply, and just like that, now we have our loads applied here. After doing our load application and we are confident about how our structure is, we can just run our first calculation analysis. And it's quite easy. So what we first do, we save our drawing. So click on save. And even before running, I clearly see that I would like to extend this specific beam that we have here. So this beam member, I like to extend it from this point to this very end point. So it has moved everything. That is not what I wanted. I can first select it and delete it. So select, delete, but I can use extend tool here. So it's very easy. So you select the specific boundary of the item that you want, let's say from that point to this point here, and then it will be able to extend it. And you can specify the type of member, specific member that you want. So you want this to be the boundary, and the member, we want it to be this one. But for our case, instead of doing that, we can just simply select on it, delete it. Then we're going to come up with a new beam. So click on new beam here. Make sure it's 300 by 300. So from this point all the way to that point. So that's better. So click on close. If I go to section shapes, I am satisfied with how things look like. So close, click on save, and now we can be able to run our first analysis of our structure. So I'm going to zoom out, click on calculations. So click on this ones, and it's starting. So this is just a warning, not an issue. Just click on yes. And you can clearly see that you have only one warning. So this is because you do not define the structure of this side. So if I was just to double click on it, you can clearly see that that is the issue. But if you just click on close, we can go back to this area. You can click on this story structure, and then you can redefine them again. So you can delete all, then add it up to 6. So once that's done, click on apply, click on yes. It's gonna just make the results obsolete, not an issue. Then click on close, click on save. Then you can try to see if the error has been resolved or not yet. So run. So the warning is still there, but it's not an issue. Everything else seems to be running all right and smoothly. And the next thing that we want to do is just to copy and paste what we have here to these other stories. And it's quite simple. We're going to simply go to story, right click on it, and then you're going to simply navigate to stories here. And then you can just select copy story or copy contents of the story. So you can click on copy story, and then you're going to select which is a template. For our case, it's story 1, and to which level at the top, above, below, at the bottom, so on and so forth. So we want to copy it above, the height of this, and the number of repetitions. For this case, it will be 1, 2, 3, 4, and 5. So key in 5 and perform the operations on selected elements of object if we had selected specific ones, but for now, we want everything. So once that's done, click on OK. So the results will be invalid. That's not a problem. Click on OK. So we can clearly see that these plus buttons are being added because we are now propagating all other floors about with the same information. And you can clearly see that our columns have been added, our nodes have been added, our beams are there, our floors are there. Everything seems to be all right. But we cannot see these other floors. It's because of the filter. So just click on this filter, and the filter will be removed and everything will be shown accordingly. So that's the way it looks like. So we can go back to our story definition and do away with these new stories that have been added from this level up to this level. So click on this, delete, 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 delete. Click on apply, click on close. And that's the way our structure looks like. And if you actually wanted to add the beautification, you can simply go to the display. So click on this display, go to mark with colors, specify story legends with colors, click on apply, and you can see the different stories with different colors, or you can even see different members or different materials. So let's say member types with different colors, and the legend will be given here, but I prefer the stories like so, and then check the members for now. And that's the way our structures look like. And you can even add this specific member shapes just to see how it looks like. And now let's run our analysis to make sure that everything is all right. So click on calculation. So this, just click on yes. So having incoherent meshes on the edges is not an issue just because you copied and pasted to all other floors. But to resolve this is quite easy. You're going to simply go to our mesh options for FE generation, and then you're going to go to our meshing option. So click on this once, all the results we want for all the panels, yes. And we're going to select the advanced option. So go to advanced. We're going to use the D-Line, and you're going to specify the D-Line and Kang. Then you can change the HO distance or the H max distance that is going to be considered here. So we can just do 1 meter, something of the sort. The Q, you can check what the Q means. The HO, what it means, the smallest distance. So you can change from here all that you want to do. You can also change the type of surface that is going to be analyzed. For our case, this is all right. Click on OK. Then we're going to generate a new mesh for our structure. Or you can even change the calculation model type from here by pressing this. You remember this option? You can specify the one that you want. So let's leave it as shell, and then we can generate our new mesh by clicking this. So load mesh generation. Yes, we're gonna change the results, And once that's done, we can now run the verification of the structure calculation. And just like that, we have resolved that error for incoherent meshes. So we can now run the total calculation. So this, click on yes. Instability, just hit on escape. And just like that, everything is okay. There's no issue whatsoever. Those are just warnings. Warnings, remember, they're not very serious. They're just the software trying to give you, maybe this can be done better, so on and so forth, but does not limit you to proceed with your design. So if you had any errors, then that can be a very serious issue, but warnings are not a problem whatsoever. If you don't want to see these loads, remember, you can just simply uncheck and you'll see the structure looking like so. So the next item that we want to look at will be our results. So the main results. So we're going to simply navigate to results, and you can see the results either for the members, either in diagrams, in maps or sections, or different tables that we have here, or within stories, cores, and even advanced information if you want. So let's say if you want to see the diagrams of members. So click on member. You can specify any member that you want. Let's say we select a heavily loaded member like this beam here. So select on this member, and then we can open it in a different new window, and then we can check either the moments, let's say in the MZ, and then click on apply. So in this specific window, we can visualize how our member is behaving, and you can even turn off our section shapes by clicking on this. So let's look at, let's say, the forces in the X, in the Z. So this is how the forces look like, and you can change from here what we want to see. Let's say even the deformation, you can see the nodal deformation of this specific member. You can click on apply and see how it looks like. And if we wanted to see the entire structure, let's say if we go back to the view over here and you want to see how the entire structure will be like, we can deform. We can start a simulation of the entire structure just by pressing, let's create a new window for this. Click on start, and you'll see how the structure is being deformed because of the loads. So this is how a structure is deforming. It's not an issue. We have not yet provided the foundations, but it can give us a very quick representation on how our structure will behave once subjected to the dead load within this case. But if you want to see the combined loads, you can even change them here and see how it will behave in different situations. Let's use the ultimate limit state in this situation, and we can be able to start our new calculation with this specific item. So let's say, for example, we uncheck this, I uncheck this, I go back to my forces, shear, and moments. Then let's apply, let's say, forces in the Z, and then click on new window, then click on apply. We can see how our forces look like here, and we can also change how these parameters are being displayed. We can use differentiated, something of the sort, and we can even use field, so that we have field data, and we can have labels of the maximum area on how the forces or the specific moments are acting, or even text at different points like so. So that's the way we do it. And if we wanted to take a screen capture, we can right click on screen capture, and you can add it to our report of this specific label, give it a comment, click on OK, and it will be saved within the specific file. You can also find the same option for screen capture over here. So once you're done with this window or this specific window, click on exit, and it will be closed accordingly down here. So if you wanted to see how a specific column is behaving, you can also select on them. Let's say this one here, and you can see how it's going to behave in the event that it has, let's say, forces from the Z direction, like so. Then click on a new window, then apply. So this is the way it looks like. We can remove the section shape just to see how it looks like. Remember, you can change what you want to see here, differentiated, fill, click on apply, and this is the way it looks like. So this is the information that you can now save and share it to the respective designer or the engineer, so as to provide the required reinforcement for this specific area. Once you're done, click on exit. Even for the diagram, you can click on this, click on exit, and we'll go back to our view. And under our view, we can just remove the deformation case that we had, our nodal deformation. Click on apply, and just like that, it's gone. So now let's look for the next results that we have here. These are maps for members. So this can be specified more detailed information about a member. So let's say we want to see how this member here acts, member 191, and we can see the forces in the Z direction, or moments, or shear, so on and so forth. You can also check the design, the scales. So this is basically how the color will be represented, as well as the parameters will be represented. So let's open a new window, click on apply. And this is the way the information is being displayed. So if I was to first close on this diagram, we can see the maximum and the minimum information being shown here. I can hide my section shape so that I see which is a critical point and which is less critical point, just like that. You can apply labels to see how it's behaving, and that's the way we use it. If we want to see moments, can apply the same thing. We can see it here, and it's a very powerful feature that we have in RSA. So let's go to maps. So this is mainly used for panels or floors. So let me show you how. So click on exit. So let's see how our structure will be behaving in the event that it has a load acting on this specific panel. So what we can do, actually we can save for the entire structure, and it's quite easy. We can open it in a new window, and then we can see how the displacements in the Z direction are going to affect it in maps, like so. Then click on apply. But initially we had already selected this beam here, so it's going to show us only for this beam. But you can click on exit, then right click here, click on cancel, so that we cancel out of everything. Then select this, then open in a new window. And from here we can visualize for the entire structure on how the forces are acting here. The maximum being this, while the minimum being this one here. So this means that we need to provide proper reinforcement for our structure, because we have some serious deformations happening here. And you can even change the scale that we're using here. Let's say to something like classic, then click on apply, so that it will change the color coding that we have here to something that we will understand very quickly by just a quick glance of our structure. So the red areas, we can visualize where exactly this point is by going to even running a simulation on how this area looks like. But you can even give the description of this specific area that has the highest level of deformation. So we can use the FE mesh, then we can just run the smoothing with the panels and just do a very quick simulation on how this structure is deforming within this specific zone. Alright, so from our analysis, you can clearly see that the connection of our beam structure here has not been done. That's why the sway is just making it fall all the way down, as well as this member down here. So we can resolve this quite simply by just going back to our model and doing a proper connection of these 2 points here. So to do that, it's quite easy. We're going to go back to view, but we have to stop these results that we have here. So we have first to stop the simulation that is happening. So click on stop, click on close. So we want to make sure that these specific members have been connected appropriately to this specific beam here, or this beam is not strong enough to support that weight, but I highly suspect that that's not the case. So we can simply use the section shapes to make it easier. So I can click on this specific beam, but from my check, it seems like it's connected. So what I can do, I can change the type of this specific member that we have here in this specific story. Let's say this one, as well as this one here, as well as this one and this one. I'm holding down my control so that I can be able to select them. So we have this one selected. So we can clearly see that we have 300 by 300. Let's use a deeper beam. Yes, the results will be obsolete. So click on yes, click on yes. So once that's done, you can, let's just first click on this to make sure that it's updated. Yes, it's updated. And then we can just run our new mesh. So go to mesh. We want to just generate a new mesh for all the panels. Yes. So once that's done, simply close, run the calculations again. So you can clearly see that they have been updated now. Alright, so we still have warnings, but no errors whatsoever. It's not an issue. Click on close. So in this video, I'll be taking you through how to provide the reinforcement of our specific members. But even before doing that, there are some loads that we have not yet defined, such as the wind and the seismic. So to do that, it's quite easy. You can navigate back to the geometry layout, and then you're going to select the load type. And under this load type, you're going to add a new type of load. Let's first add seismic. So one of them being seismic. Then after selecting it, just click on add. Yes, the results will be out of date. Click on yes. And that is satisfactory for now. So click on close. And now let's incorporate the seismic design here. So navigate to analysis types. And under this, make sure you select this seismic one that we have here. And we want to set, or we want to create a new one under this one. So make sure you click on seismic, and we have this one here. Or we are going to create a new entire seismic calculation from here. Or alternatively, you can change the seismic calculation from here as well. So for this case, let's first delete this one. It's gone. Then go to new. So the name of this one will be seismic. So you can call it ses, select seismic, click on OK. You can select the direction that you want to be considered for the eccentricity, as well as the code that you're using. So for our case is Eurocode 8. You can specify all these options, as well as the range of the seismic load from here, and also the seismic analysis parameters to be considered from here. So remember, all this information is found within the Eurocode. So this is 0.075, and then you can click on OK, then click on OK. Then after doing that, it will be added here. So for the X direction and the Y direction. So after doing that, you can click on calculate. But even before doing calculation, let's first click on close. And if we go back to our load cases, we will be able to find our newly created loads added here. So now let's add for the wind. It's very easy. Navigate to load, navigate to the wind load simulation, navigate to the generate wind loads. So click on this option once, and this pop-up window will be shown. So from here, we can specify the direction at which the wind will be blowing towards our structure. So this is the X and Y Cartesian plane you can see here. So maybe you want positive X and maybe negative Y. You can specify also the wind speed that you have within the area. So this one you can check from the data that you have. Let's say we have something like 10 millimeters per second. You can change the terrain level if it's elevated or not, or something of the sort. The elements that you want to be considered to the exposure, as well as these other generation options. You can also check on the wind profile. But for our case, let's just keep it simple. Just click on start. The simulation will start. If you're content with how it is right now, you can just simply click on generate loads now, and it is going to skip all this convergence process, and it is going to give you your loads for your X direction. So right now we are simulating for your Y direction, and you can clearly see it has been updated here, and the wind direction is coming from top, now going to the bottom, and you can clearly see how our building is behaving, being subjected to this specific wind. So remember, if you're content with how it is, you can just simply click on generate loads now. So it's going to give you this breakdown, how it was done, and it has been added to our loads. You can clearly see here, click on OK. Then you can simply just click on close for now. And if you wanted to check the kill, you can check it from there. So now we're back here and we have our newly added loads. Remember, under the analysis, you can now find also our seismic loads over here. So if you just select on it, you can even just double click and edit the analysis type that you have down here. But for our case, you're not going to change anything. Just simply click on calculate so that we see how our building is now behaving. This is just a warning, escape. This is another warning, escape. Going through the cases that we have. So now we just have warnings, not an issue, no error. Click on close, click on close. So the other thing that we might want to consider might be the combination. So you can go to automatic combinations, and from here you can specify the code that you want to refer to. Remember, we specified Eurocode 0. If you don't recall how we came about to this one, we went to our tools. So let me first close here, tools. We went to our preferences for this specific project. We went to our tools, we went to our job preferences for this specific project, and then we went to our structural we went to a design code, and under load, we found our combination where we specify the combination that we wanted to be used for this design. Remember, if you want to more, you can simply come here and you can specify the one that you want in accordance to the code that you have. So here we have, let's say, Euro code. So this one, we can use this one. So we can just click on it, add it to this other direction and set it as current like so, then click on OK. And just like that, it will be added here. For the wind loads, for the seismic loads, they're already over there, just like so, then click on OK. So in the event that we were to go back here to our load, automatic load combination, we can be able to find that specific option that we just added right now. And if we go to the full automatic, we can find that we have 49 types of combinations, which we can use for now. Just click on OK. So it's saying that if you do the results, the program will operate on default calculation. So just simply click on OK. So it's now generating all of them. So we can uncheck the accidental end fire, then click on generate. And if we go back here, we'll find that we have our combinations, such as the simple cases that have been analyzed for our structure. So let's go back to the load selection. Then we can be able to run our calculation. So in the event that you have an issue with your load combination, just simply go back here. You can even create a manual combination from here, either checking on the service limit states or the service ultimate limit states from here, checking on the parameters as we have already gone through, and then you can simply add them to your specific program and it can be able to run. You can add all of them here and check on what you want to consider and the combination number as well. And the factors is automatic, but remember you can change your factor from here as well. But for our case, you're not going to change anything. Click on apply, click on close. And if we go back here, you'll find that we have our combination added here. And for these other ones, because they're not being adopted from the code for one reason or another, you can just simply do away with them, or you can check on these others if they will give you any other type of combination. So once that's done, the next thing will be just to provide a reinforcement. So click on, let's say, this specific beam, navigate to either provide theoretically or provide the required. So this is the real reinforcement. So for this video purpose, we'll keep it simple. You can use provide reinforcement, but in our entire course, we have gone through each and every single option. So click on this option here. It's still the same one, provided reinforcement for the RC element, and we'll be guided to this window. And from here, we can specify what we want it to consider for our beam element. So simple cases, which flow that we have and which type of load that we want. So for this, you can leave them as is, or you can also consider the supports. Just click on OK. And over here, we can simply see the geometry of our section, the span as well. So under the span, we can change the name. So this is P1, then we have P2, P3, P4, and we have the width as well as the sizes. And you can also change the shape or the type of beam system that we're working with. But for now, we're not going to change all that. We can go to typical reinforcement option here, and we can give it what should be considered down here. So under geometry, it's constant because it's already predefined. Under star-ups, we can now specify what we want here. Let's say we want to use D8. The specific steel, it's okay. The hook is all right for seismic. We can use anti-shrinkage reinforcement here if the beam is quite deep. So for our case, this is not quite a deep beam, but let's just add it here. For the star up as well, leave that on as is. Distribution, we can change the calculation and how the pattern will be used. So this is all right with me, but you can change it from here. For the main bars, you can specify the one that you prefer. Let's first adopt D16 for the bottom. So remember, steel is very good in tension. So the bottom has to be more. There have to be more bars. And you can provide a hook if you want to. So for our case, you can just leave it as is, and also the length of the hook. Additional top bars you can give as well as bottom and division. So once you have specified all that, you can simply click on OK, and the software is going to do an analysis to see if it is satisfactory for this specific beam. So down here we have a schematic on how our beam looks like. So this is a total length that we have 16.3 meters. And the different segments that we have here, as well as the common column size that is shown over here. So it's currently running and checking if it's suitable for this specific beam, the reinforcement. So it has already finished running. It is checking that the environmental cover was given to 15, which is less than 25. So this is not an issue. We can just be able to edit this later on. So to do that, it's quite simple, but let's first go to the reinforcement and check if the provided reinforcement has been given. So we can clearly see that it has been added. We can orbit around and how beautiful it looks like this. So you can see the bars. If you were to select on any of them, it will be highlighted here, as well as a bar bending schedule will be provided here. So let's select this one. You can see how it is, the numbers of the bar that they are, the type, the diameter, the shape code, and also the bending, the details of each and every single bar that we have here. So we have a total of 166 bars. We have a summary table where we have the surface, the main top bar, the surface longitudinal, and the main. So it's really, really efficient here, as well as the spacing that we have around this area. We can also generate our drawing, but just by pressing on this, we'll have our drawing of this specific member. So this is the beam member that we have here. It's a really, really beautiful system that we have here, and this is drawing 1 out of 4. You can see how our bars are being arranged here. You can go to the next one like so. It's very, very efficient, and you can clearly see our section places where we have 4, 3. So this is just the point where it's peaking, and our section place being here, C, D, and they're being represented down here in a very nice and clean way. You can also change the reinforcement by going back. So for our case, let's say we want to change something of the sort. Let's say the story parameters. By clicking this, you can change the story parameter, and it will change also the thickness or the covering that is being used for this specific beam. So that's the way you can be able to edit various elements of a specific beam. So if you're interested on how to use these other advanced options, I've gone through them in our comprehensive course, and it's very efficient because you can specify each and every single item that you want for your specific beam, and this is more refined and more fine-tuned. But for our case, let me show you how to provide the reinforcement for your column. But even before that, we usually have a beam note. So this is very important to show that the calculation was done and it passed. So we can have the name of the beam, where it is placed, the location, the exposure class, the span. So this is a geometry. And then we have the calculation option. So this is as per Eurocode, the cover that was used. So here the cover does not satisfy the environment. So it means that just need to add the cover. It's not an issue whatsoever. So this is what was considered in graphically. It's been shown here. And if you wanted to export this, it's quite simple. You can just simply click on print, and you'll be able to print, or you can even have a quick preview. So click on preview here, and it will give you a preview of this specific beam node. Once satisfied, you can go back to the various items that we have here, such as the diagrams that are in the report, and you can check all the information that you want. So I've gone through all this in detail within our main course. So let's go back to structure, and now let's provide the reinforcement for our column. So let's say this column alone, you can just select it and then just click on provide reinforcement. So this window will be shown again. So just use simple cases, leave everything as is. So a column chain is just a connection of various columns within the same area. Just leave it as is, then just simply click, or even run automatically next time. So click on OK. So it's gonna bring us to this specific dialog window where we have the view of this specific column, and we can go through the same typical reinforcement. Remember, this is more advanced, which I've already covered, and it's very fine to fine-tune your detailing. But for this simple video, I can show you how to do it in a very simple way. So for our columns, let's work with something like D20. You can specify the bar that it's common in your country. So D20, remember the columns are taking the weight from, so it moves like this, where it moves from the slab to the beams, from the beams to the columns, from the columns to the foundation. So the columns have to be quite strong. So let's use D20. The material is okay. You can specify the hooks if you want. So for our case, because it's a door well, let's just leave it as is. The number of bars, let's increase them to, let's say, about 4 bars, and we'll see how it will behave. For the stirrups or the ties, we can specify this to be 135 degrees and D8. So this is okay with me, or we can change even the stirrup type to something of the sort. And then we can also change the distance in between of this. So instead of 100, we can use something like 150. And then you can change the distribution style as well over here, and also specify the distance between each specific stirrup. Under the dowel, this is just the elongation. You can specify the type that you prefer. So this is an extra reinforcement, is quite long, or you can use this overlapping system where you use one bar and then you cut and then you overlap again. Either system works, depends with the one that you prefer. So this one, let's say we use D20 as well. And then if you're satisfied with that, you can just simply click on OK, and the system will start to calculate and tell us if it will be okay. So it's telling us that there's no ultimate limit state combination. So this is just about the combination that we used, and the seismic disposition does not need any requirement. That's okay. So click on OK. Let's go to the column reinforcement. Let's see how it has been reinforced. So we can clearly see that we have a reinforcement here, and our column looks really good. You can zoom in, can select certain rebar if you want to see it. So this is the way it looks like. You can get a detail bar, you can get the summary, you can select the main reinforcement bar like so, you can get the summary, you can select for the dowels as well, you can get the summary, and you also have the section here, or the top view shown over here. So if you're satisfied with this, you can also go through the column note and read through it and check what was considered and what was not considered, what passed and what failed. So it's very efficient, and you can simply go to the drawings by clicking here, and the drawings will be generated, very clear drawings, so you can check. So these drawings are in centimeters. So if you want to change our dimensions, right now we have in centimeter. It's very easy. You can simply go back to analysis, click on the drawing parameters that we have here, and down here under units, you can now change it to millimeters. So for 1 millimeter, just use it, which is less than 1 meter, just use it to be millimeter. Then click on OK. Then let's go back to our drawing, and just like that, it has been updated accordingly. So that's the way we check our drawings and generate our reinforcement within our RSA software. So before reinforcing our slab panel, it's important to reconfirm the weight that we have acting within our slab. So to do this, let's first go to tools. Let's go to our job preference, and I want to look at the units that we have. So remember, you can check metric from here, but I want to look at the forces because we need to make sure that we are having forces. So let's first update this to meters so that we have kilo megapascals. So click on OK first, and then we're going to go to our load definition. So first load definition, then we're going to select from our load cases here. So for our load case, let's select first that load 1. So select this one here. So if it's not selecting, just select from here, and it will be updated here accordingly. And under this, go to surface, click on this planner. So we can clearly see that here we have a very serious error, which will give us crazy result. So make sure you just update it to -20 kilopascals instead of the initial calculation that was given, kilopascals, not megapascals, kilopascals. And once that's done, you can simply click on add, and it can be edited within our design. So to do that is quite easy. Go to loads, then we're going to go to our load table. So click on this, and then we're going to change our value within our load table. So under our load table, let's update it accordingly. So this one, we can move it on the side. So for the live load, this will be -2 only, like so. For our dead load, it will be -20 only, like so. And just like that, now it will update accordingly within the structure. If we go back to our model, you'll find out that our results will be out of date, but we're just going to do our quick analysis again of our structure. And let's just create our mesh again. Remember, just click on this for all the panels. So we want to select for all the panels, not just one. Yes. So once that's done, click on close, navigate to the calculation option. Let's calculate for the entire building. So the only thing that has changed is the load that we have used, but nothing else. The same steps remain the same, how to provide the reinforcement, but because the weight was too much within our panel area or within our slab area, it will have given us very serious results. So for this one, just click on escape. It's not an issue, just basic warnings. So the RSA is recalculating our combinations that we had according to the job preference that we had already specified to it. Remember, it was as per Eurocode 0. So it's going through what we have here. And you can just mainly find that we just have errors. We just have warnings, no single error, which means everything is all right. And from bottom here, we can clearly see that we have our combinations added here. So having done that, you can simply click away. Then you can select on the panel that we want to do our reinforcement. So click on this specific edge and you can clearly see it has been selected here. And then the next thing that we're going to do is very simple. Just click on provide reinforcement for the RC element. So the layout that we are under, it's under geometry. So click on this and it's going to start to calculate automatically for the slab. So from all calculations, we were getting around 40 diameter for the reinforcement of this specific slab, which does not make any sense whatsoever. That's why I was prompted to run it again so as to give the correct reinforcement for this specific structure. So once it's done, it's going to give you this transfer of RC elements has been completed. You can click on close and you can just see how the reinforcement will be given for your specific structure. So right here we have a probable solution of using D6 for the reinforcement of our structure, but you can go through the solutions that are given over here on the list of probable solutions. So you can just click on this drop down arrow, you can select the one that you prefer and you can use it, but this spacing is too much, so better just to use maybe this one. And not only that, you can also go through the settings that we have here. So the calculation options that we have here, you can click on this. You can change the spacing or the sizing and anything else that you want to change. So for our case, we can maybe use D10 to be the main bar and maybe maximum D12, maybe where we have the openings. We do not want to use any wireframes. So with that one, I will show you how to remove it. For the punching, we can use 12. Then we can save this as a new standard. Let's say something of the sort like SC, and then click on OK. So it will be saved here. Click on OK again. And then after that, you can change your story parameters from here, as well as the reinforcement parameters from here. So from here, we can just specify bars and you can change how you want them to be organized, as well as the shapes, and then can click on OK. And then once you're done with everything, you can just simply click on calculate again, and then it will recalculate this specific slab. So you can see down here it's calculating, and once it's done, it can give you a list of probable solutions that you can use. So after that, you can find this result. So if there's any error, you'll find it over here, but for now it's just okay. Just click on OK and you can find different solutions. So for now we have D10 at this spacing, or you can change and find D12 for this specific spacing. So that's mainly how you provide your reinforcement. If you're not satisfied with any of the answers or any of the results, it's quite easy. You can always unlock, you can change the type of combinations that you use for your specific design to find the most efficient and the most perfect result of your specific design. But before we close off from robot structural analysis, let me show you how to provide the reinforcement for your specific foundation. So it's quite easy. You can just highlight, let's say open your dash window from left to right to select like so, and then you click on provide reinforcement for this reinforcement element. So you'll see that it's starting to load, and after some time it will bring for the foundation. So this is for the column, no problem, click on OK. Or you can change on what you want to be considered. For our case, just click on OK for now. And now we have for the foundation. So for this one, click on OK as well. You just simply go back here. You can try to zoom out. And I'll go to the right view. You have to be more careful to ensure that everything is selected. Let's go to this other side, the front view. Then I'll try to select. So I'll uncheck the section shapes like so. And then I'll highlight this section here like so. And then I'll click on provide reinforcement. Then it will take us through the same process again. So because of the soil, it's going to use this specific regulation, but you can change if you prefer to change. And you can also consider the manual combinations if you want to, or the simple cases. So click on OK. And at level 0 is where we have our foundation. So you can click on this. So this was the first one that we had created. So we want this second one. So just simply just select it and it will be highlighted here. And we want to see the reinforcement that it's been used. So we can use the typical one here. So click on typical and you can specify the geometry, but this one is already done. So go to the bottom reinforcement. You can change the bars that are being used. So let's say 20, 20. You can change if you want hooks to be included here. You can change the spacing if you want to. You can specify the top reinforcement if you want to. You can add the door wells if you want to. You can even add hooks if you want to. You can specify star-ups for this specific pier if you want to, or you can use the user defined reinforcement. So this is the one that comes from the automatic provide reinforcement, but I don't want to use the user. I want to use a higher type of bar. So let's use 20 here, maybe the 8 for the star-ups like so, and then just simply click on OK and it will do the calculation again. So 2 small bar diameter incompatible with the code. So we need 8 millimeter and it has to be greater. So this is just basically for the pier. So click on this, specify greater, and just go with 20, not an issue. Click on OK. So no problems are found. Click on OK. You can just run the calculations again, and you can even generate drawings. So click on calculate. And over here, we now have our drawings, which you can go through. So these are foundation 1 to 59. You can have the breakdown over here, and it's quite seamless like so. So once satisfied, you can simply just close from this by going back to reinforcement. You can check on the results that you have here. So click on results, and under results, you can see how it's behaving for this specific foundation, or you can even change the reinforcement type from here. You can select the specific member. You can see how it is. You can visualize it in the 3D. This is how it's going to look like. You can have your foundation note and make sure that everything is okay. And once satisfied, you can always print this foundation note. So that's mainly how we provide the reinforcement for our structure. And in the event that you wanted to provide for the entire structure, it's quite easy. Just click away, click on cancel. Okay, so now that we have designed the structural elements, it's time to create the detailed reinforcement drawings and also to generate the necessary construction documents. So these documents will provide all the essential information for the construction phase, and it's quite easy to get it. So you can simply just navigate to this print, and you can print maybe this specific drawing. But even better, you can go to the print out composition. So if you click on this, you'll find the print out composition, where this was a screenshot that we took, and you can add it to your drawing. But for this case, we can take a new screenshot. Let's say for this specific element, you click on screenshot, then we can give it a name so that we can be able to save it within our report. So once that's done, you can even insert the date and time. You can add some comments if you prefer, and then you can change the resolution if you wanted. So just click on OK for now. Then let's go back to print out composition. So click on this. Once that's done, you can click on this. You can add it here, and then you can check on this option to add the page breaker. So after that, it will be added like so. So we have 2, and if you just double click on it, it will just give you a very quick preview on how it looks like. So this is just a preview on how our design looks like, and we have our date and our time here. So that's all right with me. If you wanted to edit, you can just simply click on edit, and you can edit how it looks like over here. You can also add some items in the report if you prefer. Let's say we want to add the members. So let's say data for the members, we add it here. We can also add information, let's say about the member definition. You can add it here. If you have displacements, you can also add them here, as well as reaction values. You can just simply select and add. So these are just simply break lines that we add in within each and every single segment. So after you're comfortable with what you want to add here, you can just simply click on this Word icon to start the Microsoft Word application, where the report is going to be integrated into this application, and you can see that the data will be imported at the bottom left hand corner. So this is the screen capture that we have gotten from our software, and the other information is being updated as well. So having my Revit software launched, the first thing I'll do is to first create an empty file or an empty project. So click on new, And this project that we'll be creating will be a structural project so that a robot can be able to send its information into this specific project. So click on that one, click on OK. So after Revit creates the template, for this case it's project 1, we can put them side by side. So I'll just hit the Windows key button and the side key so that I can place my specific software on this side, and this other software, I'll place it on the other side as well. So like this. So I want to send this information to this specific software, and I'll just double click to place it at the center. The same with this one, I'll just double click to place it at the center. Then I'll simply navigate to add-ins, integration. Then I'll navigate to Revit. I'll specify the model, send it with the results, direct integration. Then I'll click on OK. You can change this to, let's say, RC, and then you can give more information if you wanted. For my case, that's all right. Just click on OK. And now we are sending this information from RSA to our Revit software. On the meantime, we can clearly see that this has ended, the exporting of our document to Word, where we have more than 478 pages, quite a lot of data, and it's quite good. So you can just simply save it and send it to whomever you want. So let's go back here and see, well, the information is being shared between these softwares. So once the integration and export is done, you can view the report by clicking yes. So right here, we can see if we have any warnings. So these are the warnings. So some project types of the loads are not supported in the transfer process. That's not an issue. And the required reinforcement results may not be available. That's okay. So I can click on close. Then I can click on my perspective icon here on my 3D. And just like that, we can be able to visualize how our project will be looking like from now Revit and RSA. So in the event that we had shapes and we had, let's say, defined elements within this model, we can be able to visualize just like so. And if we wanted to hide these load elements, it's so easy. Just select one of them, right click and then hide by category. And that's the way they look like. So that's mainly how we design from RSA to Revit. And remember, the integration is also there from Revit to RSA just by going to the Analyze tab. And under the Analyze tab, you can find this direct link where you can be able to export this information as well as these other options that you've already gone through in the big course.
Now that was all about designing structural members using a project-based course of robots structural analysis. Now sign up for the free robots structure course and you'll get your certificate of completion as well when you finish the course 100%. The link is right here in the description of this video and also in the pinned comment. Also, let me know in the comments down below which topic you want us to cover next. Take care and have a great day.